Hey, feeling good, like I should. When in dark, walk around the neighborhood. Feeling blessed.
All right, let's check and see how you did on last night's homework or yesterday's homework. First problem is asking us to create stem and leaf plots for the given data. Let's see, Miss Whitney has 13 students who did extra credit assignments to raise their grades. The scores on the assignments were 96, 45, blah, 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 blah. Okay, so one of the reasons why we might want to make a stem and leaf plot is to organize the data and kind of see the different intervals. And so a stem and leaf plot is this kind of a plot right here. This is the unordered stem and leaf plot. This is just taking the numbers in order as they're shown, and then we can put them into order. So it looks like the lowest number is 33, and we're going to start in the 30s. And then for my stem, these are all going to be numbers that are in the tens place. So 30, 40, 50, 60, 70, 80, 90, and that would be 100. 33 goes here, 45 goes here, 67, 60, 77, and so on and so forth. So once we get every single one of these numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers accounted for here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, then we can put it into order. So the 60s need to be rearranged, so it's 60, then 67, then the 80s need to be rearranged to the 90s, and all the 100s are the same. They're all 100s, so it doesn't really matter there. So now that we've got these in order, we can actually we can find the median of this data. We can say, all right, if there were 13 of them, 1, 2, 3, 4, 5, 6, 7, the seventh one is going to be the one in the middle, right? 6 below, 6 above, and then 89 is in the middle. So that means 89 is the median. And if we want to find out what the first and third quartiles are, we just take everything below here, 1, 2, 3, 4, 5, 6. And so it looks like the first quartile is going to be the halfway point between 60 and 67. Because these are two numbers that are in the middle, we have to take their averages. So the average of 60 and 67 is 63.5, and then do the same thing here, 1, 2, 3. Looks like these two numbers are in the middle between 98 and 100, so 99 is going to be the third quartile. So having numbers put into a stem and leaf plot, as you may recall, is beneficial because we can kind of look at this like a histogram. Like these are the numbers in the 30s, these are the numbers in the 40s, there's nothing in the 50s, this is in the 60s, in the 70s, in the 80s, the 90s, and the 100s. So you get kind of like that stem and leaf plot that's been flipped over. Now, of course, I think you can tell this is bugging me. It's probably bugging you. Let's get that fixed. Much better. Okay. So, yeah, the stem and leaf plot is great because you can see the distribution of the numbers. You can see each individual numbers, and you could also see what it would look like if it were in a histogram with bin widths counting by tens, and that's what we're doing here. This is essentially between 30 and 39, between 40 and 49, and so on and so forth. Here we are doing fraction operations. I don't necessarily want to go through and do all of these. I would just state, you got to get a common denominator. And since you're adding a positive to a negative, that means there's going to be a subtraction that happens here. 48 minus 35 is 13. And since you have more negatives than positives, think of those zero pairs canceling out all the positives and leaving you with 13 negatives left over. That's the process you go through. When you're multiplying, a negative times a positive gives you a negative answer, and you just go from left to right. And turns out this can be simplified a little bit. 33 over 84 becomes 11 over 28. And then this is the key here. I'll actually work this one out. Yeah, I guess I don't have to. It's already there. You can't just multiply a mixed number times a fraction. You've got to change the mixed number to its improper fraction form. So 1 2/3 is the same as 5/3. Since it's a negative, it's negative 5/3. Now you can multiply straight across and get negative 20 over 15 and then simplify it, or do some cross reducing in between. I'm not quite sure why I put the negative. Oh, it becomes a -1. I see, because you cancel out the 5. Okay, if anybody needed to see any more of that, send me an email and I'll work it out for you and I'll explain it. That applies to every one of these problems. If there's something that I don't go over specifically, send me an email and I'll go over it for you. Here we are solving equations. This is pretty straightforward. You just, I don't know, take away 600 from each side and then divide by negative 100. Or in some cases, some people will move this over, subtracting 500 x's from 600 x's, and you get something like this. And sometimes people aren't sure what to do at this point. But just keep in mind, when you took that away, you were left with nothing. So you can still continue the process. Subtract 200, and so it ends up being 100x is equal to negative 200. So what do you multiply times 100 to give you negative 200? It's got to be the negative 2 there. Here, the most common mistake is people not sending in the dive bombers. You got to rewrite this as 6x minus 3 plus 2 is equal to 5x. And then you can combine those and call this 6x minus 1 equals 5x. Yeah, you know, I'm going to go ahead and do this just so you see it. If you take away 6x's from each side, you still got that minus 1 there, and this becomes a negative 1x. So we do the same thing we've always done. If this was 2x was equal to 4, you would know to divide both sides by 2. Well, just divide both sides by negative 1. Any number divided by itself is going to give you 1 for an answer. So you end up with 1x is equal to positive 1. That ends up being the answer. And of course, check it to make sure that it works. If you put in a 1 here, this becomes 2 minus 1 is 1. 3 times 1 is 3. And 3 plus 2 is 5. Is 5 times 1 equal to 5 also? Yes, it is. So you've just done a little mental check, verifying this is the correct answer. Go ahead and draw your box around it and feel good about that. Here we have a 5D process, kind of a word problem. A trapezoid has a perimeter of 117 centimeters. The two shortest sides have the same side length. So it's a trapezoid, so the two shortest sides, we'll call these on the side. We're going to say they're the same, so those are both x's. And then the third side is 12 more than one short side. So I don't know which one is going to be the third side. I'll just assume this one is. And then the final side is 9 centimeters less than 3 times the short side. So yeah, that makes sense that this one would be the longer one. But once again, we've drawn pictures of these before. Don't worry about whether or not your picture of your trapezoid matches what the description up here says. Just get something on paper that's a trapezoid and start labeling. And now the perimeter trapezoids have 4 sides, so you're going to add all those up. So there's an x, here's an x, there's the x plus 12, there's a 3x minus 9. And when you add up the 4 sides, you're supposed to get 117. So combine like terms. 12 and negative 9 make 3. And 1, 2, 3, 4, 5, 6 x's. Subtract 3 from each side, so 6 x's ends up being equal to what? 114. And now just take 114 and divide it by 6. 114 divided by 6, and you get an answer of 19. So that means this side right there has to be 19, which means this has to be 19, which means that needs to be 12 more than 19. And then you're going to take 19 times 3, which is 57, and then take away 9 from that, and that would give you 48. Add up those 4 numbers. Do they add up to 117? You want to check that because you got to make sure you meet all your definitions, and this is one of the definitions, is that they add up to 117. So let's take 19 plus 19 plus 31 plus 48, and that does equal 117. So we can declare our answer how long is each side of the trapezoid. So there are the 4 sides listed. 4 pieces of taffy cost 25 cents. How do we know this is proportional? If your answer was, if you don't buy any taffy, you don't spend any money, and that each piece of candy should cost the same amount, then you're exactly right. That's what makes this proportional. So you could set up something along these lines. 4 pieces is equal to 25 cents. So how much would 8 pieces be? How much would 16 pieces be? I'll just do this one. But don't you have to double the 25 cents to give you that amount since you doubled the 4? So that would be 50 cents. So that's what I'm going to do. I'm going to go through and look at all of my doubles. So there's 4 for 25 cents, which means 8 for 50 cents. And double that, that's going to be $1 for 16 pieces. If you take 8 and you triple it, 3/8 is 24, and 3 cents would be $1.50. If you take the 16 and you double it, that's going to be 16 for $2. If you take the 4 of them and you multiply times 10, you get $2.50. And when you double that, you get 80. And double $2.50, you get $5. And then our last problem. Mrs. Ferguson, your school librarian, asks you to conduct a survey of how many books students read during a year. You get the following results. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of them. Okay. So what are we going to do? We're going to create a histogram to begin with, and it says bin widths of 10. That's really important for you to understand what this means. That means that you want to count by tens. So break all of these up on your frequency table and in your histogram in groups of 10. The histogram, do you see how we're counting by tens here? That's because the bin width is counting by tens. And so that first section is going to be between 0 and 9. The next section is from 10 to 19, then from 20 to 29, and then this section here is from 30 to 39. Now, what was the minimum and the maximum? The minimum here looks like it is 4. And what is the maximum? 35? Okay, so start, so we'll have some in the 0 to 9 bin and then some in the 30 to 39 bin, but then that's it. That'll be the maximum. So we only need the 4 bins. So you go through the process, tally mark, and then how many total of them are in the 0 to 9 range? Well, let's just go ahead and check this out. We've got 1, 2, 3 of them in the 0 to 9 range. Then in the 10 to 19 range, how many do we have? Quite a few. 1, 2, 3, 4, 5, 6 of them. 1, 2, 3, 4, no, 7 of them. And then how many of them are in the 20 range? From 20 to 29, there's 1, 2, 3, 4 of them. And how many of them, let's see if I got 4 down here, yes. And how many of them are in the 30 to 39 range? That would just be 2 of them. So you could do it this way, but it's just nice to have it all organized in a frequency table so that you can take all of these and transfer them over. So here, this is 3, this is 7, this is 4, and this is 2. Now, do you see this box plot that I put over the top of it? I'm going to do the box plot down here and then come back to that for a second, because it's nice to see how your box plot laid over top of your histogram, how it kind of shows you where the middle has to be somewhere in here in this tallest bin, how the maximum is out here in this bin and the minimum is in this bin, and that a majority of the cluster happens in this section right in here. So how do we make a box plot out of all this? Well, put them in order from least to greatest, identify your minimum and your maximum, find the number that's in the middle, that's going to be your median. The number that's in the middle, since there were 16 of them, are these 2. So you find the halfway point between those 2, that's 13.5. And then everything below the median of 13.5 is included in the lower half. So 1, 2, 3, 4, 5, 6, 7, 8 of them. You've got 2 numbers in the middle, but they're the same number. So that makes it easy for the first quartile. And then 1, 2, 3, 4, 5, 6, 7, 8. You've got 2 in the middle there. What's the halfway point between 21 and 24? 22.5. So put those numbers on the number line. Let's see. This is where the 4 would go, somewhere around here. The 35 is going to go right there. Your median was at 13.5. So where's that? 12.5. 13.5 is right around here. Your lower quartile is at 10. and your upper quartile is at 22.5, which is right there. So bring those points down, draw a line between the minimum and the maximum, and then box in the inner quartile range with your median in the middle. So once again, you're looking at this to see the spread of the data. Does it appear as if there is an outlier? It really doesn't look like it. There are no gaps in your histogram, and you don't have any of these points going way off to the edge. It looks like it's somewhat of a symmetrical kind of a shape to the histogram, you know, kind of like that bell curve with one single point. Yeah, that's about it. So different data displays help you see different things about the data. And here we kind of see that there's like a pretty much an even spread, although it looks like these guys are a little bit closer in here than out here. So majority are in this cluster right around here. All right, good job on your homework. Once again, if you have any questions for me, do not hesitate to email, and I will go over some of these in more depth for you. All right, take care.
Hey, feeling